Welcome back to the DP-900 Microsoft Azure Data Fundamentals series. In today's video, we are going to cover core data concepts. This section makes up about 15 to 20% of your exam. Do not worry if you're completely new to data. I will explain everything step by step in a simple way with examples you can relate to. By the end of this session, you will have a clear understanding of data basics. This will help you not just in the exam, but also in real-world projects. Let's start with the most basic question. What is data? Data is simply raw facts and figures. For example, numbers in your bank statement, your name, age, and email when you sign up for a website, or even a video you record on your phone. On its own, data does not mean much, but when we process it, organize it, and analyze it, that is when it becomes information. Example, a list of transactions is just raw data, but when we calculate the total expenses or find the highest transaction, that becomes information. So remember, data is raw, information is refined. Types of data. Data comes in different forms. Let's break them down. Structured data. This is neatly organized in rows and columns. Example, a customer table with ID, name, email, and phone number. Semi-structured data. This has some structure but not fixed like a table. Example, JSON files, XML documents, and log files. Unstructured data. This has no predefined structure. Example, images, audio files, videos, PDF documents, and social media posts. Think of it like this. Structured data is like a well-arranged cupboard. Semi-structured is like a cupboard where things are grouped but not in perfect boxes. Unstructured is like a drawer full of random items. Relational versus non-relational data. Now let's talk about databases. In other words, how we store data. We store data in two ways, relational and non-relational. Relational databases, also called SQL databases, store data in tables with rows and columns. They follow strict rules called a schema. Example, bank account transactions. Non-relational databases, also called NoSQL databases, store data more flexibly. Instead of tables, it could be documents, key value pairs, or even graphs. Example, Instagram posts, where one post may have an image, a caption, likes, and comments, and all of this can vary from post to post. A simple way to remember is this. Relational equals structured and rules-based. Non-relational equals flexible and scale-friendly. Types of data workloads. In the real world, data is used in different ways. These are called workloads. Transactional workloads, also known as OLTP. These involve lots of small, frequent operations. Example, every time you swipe your debit card, one record is inserted. Analytical workloads, also known as OLAP. These involve large complex queries on huge amounts of data. Example, a retail company analyzing 5 years of sales to find the best-selling products. Streaming workloads. These involve continuous real-time data flow. Example, stock prices updating every second or IoT sensor sending temperature data live. An easy analogy is this. Transactional is like adding items to a shopping cart. Analytical is like an end-of-year sales report. Streaming is like live cricket score updates. Finally, let's look at data processing methods. Batch processing. This collects a large amount of data and processes it together. Example, a payroll system that calculates everyone's salary once a month. Streaming processing. This processes data instantly as it arrives. Example, a fraud detection system that blocks a suspicious transaction immediately. Analogy: batch processing is like cooking a big meal for the whole family at once. Streaming is like serving snacks instantly as they are made. Let's do a quick recap before we wrap up. Data types: structured, semi-structured, and unstructured. Databases: relational SQL versus non-relational NoSQL. Workloads: transactional, analytical, and streaming. Processing methods: batch versus streaming. If you understand these basics, you will find it much easier to learn Azure services in the next modules. Great job sticking through this session. You have just built a strong foundation in data fundamentals. See you in the next one.